Okay, by now you should have your unit circle created. And what we're going to do is take our trig functions, our sine, cosine, tangent, and apply them to these triangles that we have fit into the unit circle. Okay, this should be review, but sine is opposite over your hypotenuse. When we talk about opposite, we're talking about opposite of that angle T. Side not touching that angle at all, so here's the opposite. Hypotenuse, longest side of the triangle, or opposite of the 90 degree. Cosine is adjacent over your hypotenuse. Adjacent means next to but not the hypotenuse, so this is the adjacent side. Hypotenuse stayed in the same place. Tangent is opposite over adjacent. Opposite over adjacent. Opposite would be straight across from T. Adjacent would be next to, not the hypotenuse. Tangent doesn't have anything to do with the hypotenuse. Okay, if we put this into the unit circle, we always know our hypotenuse is 1 if we're in a unit circle. And my other two sides, the one going straight across from T would be my opposite. And the one next to it that's not the hypotenuse is the adjacent. Or in terms of x and y, still my hypotenuse is 1. Opposite of T is a vertical line, which would be our y distance. The horizontal line would be our x distance. Just like when you draw, you've got your x and your y. X is your horizontal, y is your vertical. So x is your horizontal, y is your vertical. Okay, there's 3 more trig functions besides cosine, sine, and tangent. Cosecant is the reciprocal of sine. So it is hypotenuse over opposite. Secant is the reciprocal of cosine, so it's adjacent over hypotenuse. Cotangent's the reciprocal of tangent, so that means this is adjacent over opposite. Sides are still in the same place, just talking about them in a different order. Okay, let's put this into the circle. If I have what's given, and I need the 6 trig functions, so sine, cosine, tangent, cosecant, secant, cotangent. Okay, I'm going to enlarge this triangle out to the side here. Here's my theta. My x distance would be my x coordinate, so that's 12/13. My y distance is that 5/13. I am missing having the hypotenuse, but that's easily solved using the Pythagorean theorem. A squared plus b squared equals c squared. So we're going to take a and b are interchangeable. So 5/13 squared plus 12/13 squared. That's going to equal our c squared. So I need to figure out that fraction, take the square root of that. So I'm taking the square root of 5/13 squared plus 12/13 squared. Comes out to be 1. A lot of work for that. Okay, now let's get to the trig functions. Let's talk about sine theta. You always do sine of an angle, cosine of an angle. Sine theta, remember, is opposite over hypotenuse. Opposite side would be 5/13 over 1 would be 5/13. Cosine theta, adjacent over hypotenuse. So 12/13 over 1, or 12/13. And then tangent theta, opposite over adjacent. Let me move the page up a little bit. Opposite over adjacent. So I'm going to have 5/13 over 12/13. You remember how to divide fractions? The top one stays. We multiply by the reciprocal of the denominator. In this case, my 13s do fall out, and so I'm left with 5/12. Now's the easy part. If I do the reciprocals, reciprocal of sine is cosecant. So cosecant theta would be, flip it over, 13 over 5. Secant theta, reciprocal of cosine, 13/12. Cotangent theta, flip over tangent, I've got 12/5. Okay, instead of giving us the picture, all it's giving us is the angle, and we come up with the picture. So first of all, what quadrant am I in? I've got to locate it on the unit circle. Pi over 6 is going to fall into unit 1, or I'm sorry, quadrant 1. So here's pi over 6, so I know I'm in a 30, 60, 90 triangle. I've got to know my sides. So this is the equivalent of 30 degrees, and I know opposite of that is 1/2. My hypotenuse is 1, and I know my long side is radical 3 over 2. Those came from our special right triangles we created. Okay, so now I make my 6 trig functions right from here. So I do sine of pi over 6 equals opposite 1/2 over hypotenuse 1. So that would be 1/2. Cosine of pi over 6 would be adjacent, radical 3 over 2 over 1, or just radical 3 over 2. Tangent pi over 6, opposite is 1/2 over adjacent, radical 3 over 2. Now we have to multiply by the reciprocal here, so 1/2 times 2 over radical 3. The 2's fall out, 1 over radical 3. Now you may think that looks funny because it's not rationalized. I will accept that answer, but in the case that you need a rationalized answer for, say, a multiple choice question, we rationalize by multiplying radical 3 over radical 3. Now it comes out to be radical 3 over 3. Okay, my reciprocal functions. Let's get a different color for them. Okay, so reciprocal of sine, that would be cosecant pi over 6. Flip it over, I get 2. Reciprocal of cosine, secant. Secant of pi over 6 would be 2 over radical 3. Or if you feel like you need to rationalize, or if it's a multiple choice test, we could always do multiply it by radical 3 over radical 3 and come out to get 2 radical 3 over 3. Okay, cotangent of pi over 6. I'm going to flip over the answer I had before I rationalized. Because if I flip this answer over, I'm going to have to rationalize again. So flipping this one over, their equivalent, is going to give me radical 3. Okay, first we need to locate negative 2 pi over 3. So if I think of it in thirds, I've got to go negative. So negative 1/3 pi, negative 2/3 pi, because here's negative pi. Okay, so my angle ends up right here. So this right here is negative 2 pi over 3. My triangle always goes to the x-axis. I need this little angle in here, which is going to be pi over 3. I know that opposite of pi over 3 is my long side, so that's radical 3 over 2. My short side's 1/2, and my hypotenuse is 1. A little different here. We're negative x direction, so this is negative 1/2, and we're negative y direction, negative radical 3 over 2. So now I go to find my functions. Sine of negative 2 pi over 3 equals opposite negative radical 3 over 2 over hypotenuse, which is 1, so we don't need to worry about that. Cosine of negative 2 pi over 3 is adjacent over hypotenuse, so negative 1/2. Tangent negative 2 pi over 3 would be opposite negative radical 3 over 2 over adjacent negative 1/2. Got to multiply by the reciprocal here, negative radical 3 over 2 times negative 2 over 1. So that's a positive radical 3. Okay, my reciprocal functions, cosecant negative 2 pi over 3 is going to end up being negative 2 over radical 3. Notice they keep the sign. And I rationalize that, I get negative 2 radical 3 over 3. Secant of negative 2 pi over 3, that one's easy, negative 2. And then cotangent of negative 2 pi over 3. So flip over radical 3 to get 1 over radical 3, rationalize radical 3 over 3. Okay, you try this one, pause it, we'll come back and look at it. Okay, this should look familiar. First of all, we had to locate 4 pi over 3. So if I think of my pi, or my coordinate plane into thirds, here's 1/3, 2/3, 3/3 pi, and then I got to go one more, so I'm going to be down here. 4/3, which means I'm going to have a third left over. So opposite of the pi over 3. That's not right. Okay, take a look at this. If you noticed, it ended up being the same place, but in the positive direction. So 4 pi over 3 ends up over here in quadrant 3. Little leftover of pi over 3. That's the long side, so negative radical 3 over 2 is my long side. My short side is negative 1/2. Go through all the trig functions, check your work. Okay, this one's going to be a little bit different because pi over 2 lands right here. And we can't make a triangle with that. So what we have to think about is in terms of x and y. So in terms of x and y, when I have my theta here, this is my y distance, this is my x distance, and I'm in my unit circle, so my hypotenuse is 1. If I'm talking about sine of theta, that's going to be opposite over hypotenuse, which is just going to be y. If I talk about cosine theta, it would be adjacent over hypotenuse, or x. Tangent theta would be opposite over adjacent, so y over x. Now we're going to use these to pick out the coordinate points. Okay, if I'm in my unit circle, my coordinate point for pi over 2, my x distance is 0, but I did go up 1. All right, so my sine of theta, that's sine of pi over 2. So sine of pi over 2 is going to be the y coordinate right there, which is 1. Cosine of pi over 2 is going to be the x coordinate, so 0. Tangent pi over 2 is going to be the y divided by the x. So the 1 divided by the 0, which we cannot divide by 0, so undefined. Your reciprocal functions, your cosecant of pi over 2, if I flip over 1, I still get 1. My secant of pi over 2, if I flip over 0, I get 1 over 0, which is going to be undefined. And my tangent, I'm sorry, my cotangent of pi over 2, if I flip over 0 or 1 over 0, I get 0 over 1, which does come out to be 0. So just because tangent was undefined does not mean cotangent is undefined. Again, cosine was defined, but secant is undefined.